Hello Algebra 2 students. We are going to finish up Chapter 2 with this last video, 2.8, Linear and Absolute Value Inequalities. So we're going to be able to graph linear and absolute value inequalities in this video. So one thing you need to remember is that when we're graphing linear inequalities is that a less than sign and a greater than sign, you're going to have dotted lines. And less than or equal to, greater than or equal to, you're going to have a solid line. And also as we do this, we're going to remember we only shade over our solutions. So we're not just going to be graphing lines, we're also going to be shading over solutions because there's many solutions with inequalities, as we saw with in the last chapter with our number lines. We had to cover lots of solutions. So these are some things to remember as we're graphing those linear and absolute value inequalities. So we're going to go ahead and graph x plus 4y is greater than 2. Alright, so step number 1, we are going to get this in slope-intercept form. So we're going to subtract x from both sides. So we have 4y is greater than a negative x plus 2. And then we're going to divide by 4. So we have y is greater than a negative 1/4 x plus 1/2. And we're going to graph this line like we normally do, but we're going to decide whether or not this line is solid or dotted. So this line is going to be dotted because it's a greater than sign. So to graph these, remember we start at 1/2, and the slope is telling us to go down 1, to the right 4, 1, 2, 3, 4. Or we could go up 1, to the left 4, 1, 2, 3, 4. And this is going to be dotted. So we have a dotted line here. And now we need to decide where to shade. Because remember, it's y is greater than this line. And when we decide to shade, I'm going to use a highlighter here. Actually, I'm going to show you work to decide where to shade. We want to decide a point to pick. So for example, let's say I want to pick 1, 2. So I'm going to pick 1, 2 and see if it's a solution. Remember from the previous slide, we only shade over solutions. So let's plug this in. So is 2 greater than a negative 1/4 times 1 plus a half? So is 2 greater than a negative 1/4 times 1 is negative 1/4. A negative 1/4 plus 1/2 then is going to be a positive 1/4. So is this a true statement? This is true. So this is a solution. So we only shade over solutions. So since 1, 2 is a solution, we're going to go ahead and shade over it. And I'm going to use a highlighter. You can just shade with your pencil if you want to. If you have highlighters or colored pencils, if you want to shade doing that, you can. But this is what graphing inequalities looks like. So take a moment and write down all those steps that we just did so you have it in your notebook. Alright, next example. Graphing absolute value inequalities. So if you notice this, remember we're going to have a V. I'm just darkening up my graph here. We're going to have a V, and y is already solved for, so this is going to be a, this is going to be a solid line. So remember that's solid. And by our transformations, we know that this is going to be shifted down 4. So our absolute value graph is going to be shifted down 4. And we're just going to go ahead and make those and then connect them, make the dots and then connect them. And you can even check with a few points to make sure your points are right. If I plug in 4, am I going to get 0? Yeah. So let's go ahead and graph this. Make it purple here. And it goes like this. So now let's pick a point. So I'm going to pick an easy point. Make my life easy. I'm going to pick 0, 0. So is 0 greater than or equal to the absolute value of 0 minus 4? Well, the absolute value of 0 is 0. And 0 minus 4 is going to be a negative 4. So is 0 greater than or equal to a negative 4? That is true. So this is a solution. So I'm going to shade over 0, 0. So that's going to be inside my V here. I'm going to shade inside of it. So that is how we graph linear inequalities and linear absolute value inequalities. We're taking a step further with the shading and deciding if it's dotted or whatever. So come with questions if you have any, and we'll practice this in class tomorrow. See you later.